Alrighty, hey, thanks for tuning into this video about the solutions to the math, to the practice test review questions here. Okay, in this first problem, we're trying to graph the function y equals log base 3 of x. And you may have remembered from other problems like this that it's just kind of this swooping curve like this. That's what a log function looks like. Or you may have remembered it as kind of like the inverse of an exponential curve that kind of goes up like that. And both of those are good. But I wanted you to get a little bit more specific here in this problem and actually give me some coordinate pairs that would satisfy this equation. So it's kind of a hard thing to do just from that because you're still getting familiar with logs. But what you can remember to do is that a log equation or a log function is another way to write one is using this little snail idea where we take the base and raise it to that exponent and it equals this value here. So we could write that y equals log base 3 of x as 3 to the y equals x. This makes it a lot clearer when we try to think about xy pairs that make this true. So in fact, if I think of some values for y, I can easily calculate what the x value is. So it's a little bit reversed. If I think of the y values first, I can come up with the x values. If y is -1, then 3 to the -1 equals 1/3. If 3 to the 0, that equals +1. If y equals 1, then that's 3 to the first, that equals 3, and 3 squared equals 9. So here's some coordinate pairs in this table. Now I'm still plotting x, y. So for example, 9, 2, that's way over here, and there's my point, 9, 2. Over here is 3, 1, and here's 1, 0, and here's -1, 1/3, -1. That's this point right here. So there are some points on this curve, and I'm kind of getting at that idea here about the inverse. This is the inverse equation of log base 3 of x, y equals 3 to the x. Notice that it's just the inverse of that as well. It's taking the x and y and switching places. So the inverse of a log is this exponential idea, 3 to the x. And if you wanted to get some coordinate pairs on this inverse equation, all you would have to do would be to switch x and y values. Okay? So there we go. Let's do the next couple problems there where you are taking a log expression and kind of expanding it out into a sum of logs or maybe a difference of logs. So we have log of x times y cubed. Well, that's log of x plus log of y cubed, but I'm taking that exponent of 3 and moving it down in front of the y value, in front of the log like this. So it looks like this, log of x plus 3 log y. Over here in this problem, similar, except that I've also got a subtraction because I've got log of a quotient, log of a fraction. So that square root of y, that becomes 1/2 log y, and I'm subtracting that. So I have log of 5x, but actually 5x is a product, so I can split that up even further. So log of 5 plus log of x, and then minus the 1/2 log y. In the next problem, it's natural log, or ln, and it's a quotient, and I've got x minus 2 on the top and the cube root of x on the bottom. So x minus 2 here does not split up. You cannot break up a sum or difference within a log like this. So you have to keep it the same. But the 1/3 times natural log of x, I can write that denominator part like this. Okay, next problem, we are skipping number 5. We didn't have time to do that, so we're not going to do those. On the other side, though, let's see where we got. Here we go. Here's the first one. So I'm solving some equations right here. And these two equations, you solve them by taking the log of both sides. Okay? So on the left one here, part A, you take the log of both sides and you bring this exponent of x down to multiply log of 10. So I'm taking the log 10 of both sides of the equation and then use that power rule to bring this exponent down and wrap it around and multiply. Now, log of 10 just equals 1. So x times 1 is just x. So I've got log of 80 on the other side, so that just means that x equals log of 80, which on my calculator is about 1.903. On the other equation here, it's virtually the same, except the first thing I have to do is get rid of that 4 there by dividing both sides by 4. But after that, it's about the same. I take the log of both sides, I bring the x down to multiply, then I realize that log of 10 equals 1, so it's just x equals log of 900. and that's about 2.954. In the next pair of problems, we're going to use the snail idea to take the equation out of its log form and into an exponential form. And that way we can solve it pretty easily. So log base 2 of x equals -1. That means that 2 to the negative first equals x. And then we recall that 2 to the negative first, that's just a way of writing 1 over 2. So that means that x equals 1/2. Over here, same problem, same situation I should say. 3 to the 3.5 equals this x plus 15. All right, so I got to get a calculator going to figure that out. It's about 46.763, that's a 3. That equals x plus 15. It equals the entire thing here in this log. So all I got to do is subtract 15 and I get this number, 31.763 equals x. So in the third group of problems, we're solving these by rewriting the equations with equal bases, okay? So 5 to the 2x equals 125, which is the same thing as 5 to the third. So I have 5 to the 2x equals 5 to the third, and then once the bases are equal, you just look at the exponents. 2x equals 3, so x is 3/2. Over here, we're subtracting two things, and the result of that is 0. That must mean that these two things are equal to each other. So this equals this. That's the only way you can subtract this one and have it equal 0. So I write the equation this way. Log base 5 of x plus 6 equals log base 5 of 3x. Well, if those two things are equal to each other, that must mean that x plus 6 and 3x are equal. It's the only way that works. So x plus 6 equals 3x. I'm going to subtract this x from both sides, leaving the 6 over here equals 2x, so x equals 3. Okay, these other ones here, we are just it's sort of like solving an equation, it's sort of like evaluating also. I'm just figuring out what x is, using the snail. 3 squared equals x, that's 9. Over here, 2 to the x equals 16. 2 to the 4th power equals 16, so that's x equals 4. X to the 3rd equals 64. That happens to be true for when x equals 4. Okay, 4 to the 3rd equals 64. Down here, 5 to the x equals 5 to the negative 2. Well, okay, there we have equal bases again, so x equals -2. Over here, 3 to the 6.5 equals 3 to the x. Very similar problem, just like this one. So it's 3 to the 6.5 equals 3 to the x. Well, okay, x must equal 6.5 then. There's nothing else to do there. This one here, 2 to the x equals square root of 2. Well, I can rewrite the square root of 2 as 2 to the 1/2 power, all right? Every radical can be replaced with an exponent. And so that means that 2 to the x equals 2 to the 1/2, so x is 1/2. Last group of problems here where we're condensing or combining these 3 log things into a single logarithm. Well, we're just adding logs together, so we just multiply our terms here. And this one, this 2 here, becomes an exponent of x, so it's x squared. This 3 becomes an exponent of y, so it's y to the 3rd. But the 3 there is just all by itself, so it's log of 3 times x squared y cubed. And the very last problem here is very similar, except now I'm also going to do some subtraction, which means I'm going to have something on the bottom of the fraction. So 5 log a, that's like log of a to the 5th, all right? And 1/2 log c, that's like log of c to the 1/2, or square root of c, okay? Remember we did that, where was that other one? Right here. Square root of 2 is 2 to the 1/2, and so c to the 1/2 is the same as square root of c. It works both ways. But a to the 5th and square root of c, those are both positive, so those values will be on the top of the fraction, and this is the only negative one here, minus log b, so that goes on the bottom of the fraction. So here's your answer for that problem. I hope this video was helpful. Please watch it as many times as you want, and go back and look at the other video that I posted about solving equations using logarithms. Check the rest of your notes. Get a calculator, folks, so that you can take logs during the test. All right, very critical thing. I hope you find one. I only have a couple to loan out. So good luck with all of that. Let me know if you have any questions. And come into the classroom at lunchtime if you have any other questions or last-minute things you want to straighten out. And we'll see you tomorrow. Bye.